Composite functions. Composite functions consist of a series of simpler functions. If we have the functions f of x and g of x, a composite function could be of the form fg of x, or ff of x, or gfg of x. The fg of x means f of g of x. So you do the g first, then the f. So the order of operation, you apply the function g. First it's close to the x, then you do f of that function. Sometimes it's written like that f, little certain g, which looks like fog. So we have f of x is x plus 7 and g of x is x squared minus 3. Let's look at fg of 4, which is just f of g of 4. So let's evaluate g of 4. So substitute x equals 4 into the function g, which is 4 squared minus 3, which gives us 13. So now our f of g of 4 is just f of 13. So f of 13 is 13 plus 7. So that means that fg of 4 was 20. But algebraically, what does it look like? Because x plus 7, x squared, are simple functions. So a more complex function can be maybe do f of g of x. So g of x is x squared minus 3. So let's replace that into f of x squared minus 3. So that'll just become x squared minus 3 in place of x, and plus 7. So that gives us x squared plus 4. Okay, so an example here with these two functions, f of x is 2x plus 1 and g of x is x squared plus 1. So we're going to find fg of 3, then we're going to find fg of x. So fg of 3, let's put 3 into g, so that becomes f of 3 squared plus 1, which is f of 10. So substituting x equals 10 into the function of f, 2 times 10 plus 1, 21. And then for the algebraic one, fg, so we'll do f of g of x. So let's do f of x squared plus 1. So in the function f of x, replace where you see x with x squared plus 1. So it becomes times by 2 and add 1. So times x squared plus 1 by 2, then add 1. And expand and simplify, and we get 2x squared plus 3. So if you have a go now, we've got f of x equals 5 minus x and g of x equals x squared minus 4. And try and find gg of 2 and gf of x. Pause the video, have a go and come back and check to see how you've done. Okay, so gg of 2, we put 2 into g, you get 0. So then g of 0 is minus 4. So gg of 2 is minus 4. gf of x, we're going to replace x in g of x with 5 minus x. So 5 minus x all squared minus 4. And if you expand and simplify, you get 21 minus 10x plus x squared. Either of those answers is fine because one is expanded version, the other one is in the completed the square form, so that one is useful for sketching and finding minimum and maximum points. Okay, this time we've got f of x is 2x plus 1 and g of x is 3x minus 5. This time I'm going to solve an equation. We solve that gf of x equals 46. So before we can do anything, we need to find that composite function. So gf of x is g of 2x plus 1. So replace x in the function of g with 2x plus 1. So times by 3 and subtract 5. So gf of x will be 3, lots of 2x plus 1, minus 5. Expand and simplify, we get 6x minus 2. Now we solve that, equal to 46, and the nice simple linear equation there, 6x is 48, x must be 8. Okay, your turn now. Have a go at this one. We've got f of x equals x squared minus 2, and g of x is the square root of x plus 5. And you need to solve fg of x equals 9. Use the example on the left hand side as a guide. Pause the video, have a go, and come back and check your answer. Okay, fg of x is f of the square root of x plus 5. So f requires to square x, then take away 2. So this time we're going to square the x plus 5, root of x plus 5, and then take away 2. So that will be x plus 5 minus 6 gives you x plus 3. And now put that equal to 9, x is 6.